Fundamentally, the wind industry is changing right now. We're moving away from just thinking about groups of wind turbines as a farm to really thinking about them as a wind power plant.
The Atmosphere-to-Electrons initiative by the Department of Energy is a consortium that was put together to take wind energy into the future. As the name states, understanding the physics of the inflow coming into a wind plant helps us operate the wind turbines in the most efficient way and maximize the electrons being transmitted into the grid.
Atmosphere-to-electrons is intended to provide an unprecedented understanding of how wind plants interact with our atmosphere. Based on that understanding, we'll be able to develop new control paradigms for wind plants that will optimize how they operate and interact with our grid and maximize the energy that they produce.
So the work done by A2e is helping us define the wind turbine of the future. It's helping us reduce uncertainty where we site turbines, the energy forecasted from those turbines, how we can operate those turbines over the life of the wind farm.
So the activities under A2e are going to help benefit the wind industry by really helping to clarify the overall capabilities of wind power plants to provide these grid services in a much clearer manner to help maintain system reliability and also help maintain a low-cost grid.
The equipment manufacturers have been really pushing the envelope of building larger turbines and more efficient turbines. The whole industry is trying to drive the levelized cost of energy down so that the wind industry is economic and competitive.
So current wind turbines are highly optimized, but they operate individually. The wind plant of the future needs to take these hundreds of turbines and get them to work collaboratively.
What we're trying to do is look at the wind plant as a whole, rather than looking at individual turbines. And so we want to understand the interplay in between them and how they affect one another and optimize these systems as such.
The wind comes from a certain direction. All the wind turbines in the park point in that same direction and get the most energy they can individually out of the wind. The wind park of the future, with this work we're doing with the DOE, you'll see the group of wind turbines all pointing slightly differently, but because of that, each one is making more power than they would have individually if they hadn't been working together as a whole.
So no one organization can do it alone. Even for a company the size of GE, it's still a very difficult problem to solve. So we need the collaboration between national laboratories, academia, and industry partners like GE and others to really tackle this problem and help us quantify our fuel source.
The next generation of wind plants is yet to be discovered, and to ensure future industry growth, developing innovative technologies to maximize energy extraction from the wind is essential. The energy systems of tomorrow will have machines that work in cooperation with one another to capture energy and deliver the most cost-effective electrons into the grid. We envision a future where machines are self-organizing. They have awareness of each other through sensors and implementing control strategies so they can optimize themselves at any given point and under a variety of conditions. And the question for us is how to do this cost-effectively and reliably to provide wind energy at the lowest possible cost for the nation.